Hello there, Algebra 3 students, and today we are looking at multiplying and dividing rational expressions. So remember that when you had fractions like 2 over 4 times maybe 3 over 5, we would just say 2 times 3 over 4 times 5, and then we would get our answer, correct? So in this case, we would get, we'd get 6 over 20, right? And then when we had division, if we had 2 over 4 divided by 3 over 5 or something like that, then we would say 2 over 4, and then we would say times 5 over 3. And then we would do the same thing, 2 times 5 over 4 times 3, if there were no common factors. In this case, there are. So here where we get 6 over 20, here we would get 10 over 12, right? And simplify it to 5/6. Okay, the same thing is going to hold true for rational expressions. When we multiply them, we apply those same mathematical properties or principles. So what we're going to do here is that we're going to go straight across the top and straight across the bottom here and put it together as one fraction. And then what we have is we're going to cancel the common factors. So in this, the common factors that I have are, I have an x here, and that's going to make this 3 a 2. And then I've got a 4 and a 2. There's a common factor here. These become 1s. And then the 2 goes into the 4 2 times. So there's nothing else that's going to cancel. So we're ready to state our answer here is 2. And then it's going to be x squared times 3x plus 5 all over, it's just 7x minus 1. Now we could leave it in that form. 7x minus 1 is the only factor that's left in the denominator. Or we could state our final answer as 6x cubed plus 10x squared by distributing the 2x squared over 7x minus 1. Either one of these is fine, okay? All right, the next one is x squared minus 9 over, and these are all quadratics, right? So you have to remember that we didn't have any factoring really to do on the last one, but remember when I said we're going to factor, cancel, and simplify? When we simplified rational expressions, we're going to do the same thing. So the first step is you look at everything that you have, you're multiplying these two rational expressions. So the key here in working with them is to simplify, factor anything, not simplify, but factor any expression that you have in either the numerator or denominator, because you want to be able to cancel common factors. So if you look, I've already factored each of the quadratics that we have, the difference of 2 squared, x squared minus 9 in green, 4x squared minus 25 in peach, and then in light blue you see 2x squared minus x minus 10, and then in that green that you see x squared plus 4x minus 21 factors as x plus 7, x minus 3. Okay, so then what we're going to do is we're going to go through it and we're going to cancel common factors. So where we have an x minus 3, that cancels. Where we have a 2x minus 5, that cancels. And if you notice, go straight across the top. There's only an x plus 3 and a 2x plus 5 factor left, and an x plus 2 and an x plus 7 in the denominator. So there remains nothing else so we factored, cancel. There's nothing else that we can cancel. So we have x plus 3 times 2x plus 5, and then that's over x plus 2, and then that's times x plus 7. So then we could distribute this and we would get 2x squared, where we get plus 5x plus 6x plus 11x then, plus 15. I'm doing this pretty quickly, so I'm hoping that was right. So then in the denominator we get x squared plus 9x plus 14. Okay, and either one of these answers, depending on what you want, is correct then. So factor, cancel, and then simplify for your steps FCS for this. Okay, next one we have is 6x squared over x minus 3, and it's being divided. So now we're switching over from multiplication to division of fractions. So we're going to take and multiply by the reciprocal. So you see the first step that I took here, I changed division to multiplication and multiplied by the reciprocal, x plus 1 over 4x to the 7th. So then I moved everything together in this second step, as I move it together. I've got it all nicely set up, and you can kind of see at this point, this is like that level 1 game, if you will. There's not really a lot to do here. We're just going to cancel the x's and the 6 and the 4. We have common factors. So we have an x squared that's going to cancel with an x to the 7th. That's going to be a 5 then. And then the 4 goes into, or 2 goes into 4 2 times, and 2 goes into 6 3 times. So in the numerator, we then have 3. Let me get back to the blue. 3. And then we have x plus 1. And that would be over, it would just be 2. I'm going to move that up front. 2x to the 5th, and then it would be times x minus 3. Now you have no common factors. We could go ahead and say that's 3x plus 3 over 2x to the 5th times x minus 3. And there you have it. There it is. There you go. Okay, that's example number 3. And as I said, like there are times where it's fine to leave it in factored form. In fact, sometimes that factored form is a little more helpful. Then we have example number 4, where we have this long thing going on, but don't be intimidated by that. Just take it apart at a time. So remember, you deal with the parentheses first, right? So I go ahead and change the division to multiplication of the reciprocal. And then we're going to factor anything we can factor. So, and we're also going to move everything together, right? We're going to go straight across the top, just as I have it laid out, and the same thing in the denominator. Now we're going to cancel common factors. So if you notice x minus 8, there's nothing in the bottom. X plus 6, oh, we have 1 here and 1 here. We can cancel those, simplifying. Then I look at x plus 4. I've got 1 here and 1 here. And I don't have an x minus 4 in the denominator, so I can't cancel that. That's got to stay there. But then I have a 6 and I have a 3. So 3 is going to cancel with the 6. 6 becomes a factor of 2. 3 goes into 6 2 times. And then I have this extra x plus 4 here, which cancels with that x plus 4. So now we can simplify the whole enchilada. So in the top we have left over. Always good to glance to see what you have left, making sure you've canceled everything you need to cancel. X minus 4, and then there's a factor of 2 left. And in the denominator, don't forget you have this factor of x in there. It just kind of creeps in there. We have the factor of x, and then let me do this real quick. Factor of x, and then after the x, we have an x minus 3 and a 5. So we're going to write that as a 5x, and then times x minus 3. So there you have your answer, but what we're going to do is we're going to multiply this. So we're going to leave the 2 out there, and we get x squared minus 12x plus 32, and that's over, then we have a 5x squared minus 15x. And we could continue to say this is 2x squared minus 24x plus 64. Okay, and then that's over 5x squared minus 15x. Okay, there you have it. There you go. There it is. Now, on all these problems, I'm focusing on the problem itself, and I'm not talking about the domain restrictions in today's lessons. I'll do that tomorrow. I'll do that in the next lesson. Okay, now we have this multiplying and dividing using functional notation. So I have f of x and g of x, and we want to find an equation for the product of the function f times g. So when you see this oftentimes, this does not mean f times g times x. That means f times g of x. So it means just take f of x and multiply by g of x. So I've already got that laid down for you. Remember, at any time you can pause the video to review what we're doing. So I have the first factor, I've got f of x here, and then times g of x here. And then all I've done is moved it together in the numerator, and here you have it. We're going to work with just one fraction that you see here then. Numerator and denominator have been factored, all the factoring that I can do, and now we're going to start to cancel. So we've factored, so there's your f, and now we're going to cancel our common factors. So we've got 6 minus x. Well, what do we have here? A 5. 5 goes into itself once. It goes into 15 3 times. X and x to the 4th makes that an x cubed in the denominator. And then we have an x minus 6 and a 6 minus x, which factor not as 1, but a factor of -1. And that looks to be all we have here. So what we get is a negative times 7 negative 1, if you will. 7x minus 5 in the numerator. Now we've got all the factors there. Notice I just made that a negative instead of a negative 1 factor. And then in the denominator, we've got a 3x cubed. I tend to put the monomials first there. So 3x cubed is left down there. And then it's times x plus 6. So this is the answer. Now, if that's the answer, keep in mind, sometimes it's a little more useful. We could put the 7x, there are different ways that we can write this, and you should be aware of that. We could leave this as 3x cubed times x plus 6. But there are other times where we say it's kind of handy to just make this. If we apply the negative to the top, to the numerator, we can write it as 5 minus 7x, and then over 3x cubed times the quantity x plus 6. So let's say that this is the form that we're going to choose for our final answer. And then I'm going to come over and I'm going to say, okay, that's part 1. Now I want to do this f times 2 of g. So what we can do is we can take this 5 minus 7x and then over 3 times x cubed times x plus 6. So now what we're going to do is we're just going to input 2, okay? And then we'll put 2 here and 2 here. So what we get for an answer then is 5 minus 14. 5 minus 14 is negative 9. So we get our answer is negative 9 over 3 times 8 is 24. 24 times 8. So we have 24 times 8. That's 160 plus 32 is 192. I think. Is that right? 3 times 8 is 24. 24 times 8. 24 times 8 is 160 plus 32. So there we go. And here's our answer. Not really beautiful, but, nonetheless, they're real numbers that we deal with all the time. Okay, so we have both of our answers in number 1 and number 2 in example 2. And example 3, you can see that I have 2 functions here, and it's really the same kind of thing, but I want to highlight this, that we sometimes end up with what's called complex fractions, and they're not really beautiful. So with the complex fraction, we'll be studying those in particularly in the next lesson. So we want to write this f over g. We first write it as the f over g that you see here, but it's kind of confusing. So we can write that, like I said up here, as a division problem. And when we do, we multiply by the reciprocal then that you see here. And then our next step is to just move everything together like I had done before and factor each expression. So if I factor, let me make it a little smaller. If I factor each expression, you can see what I get there. Let me go back here. And so you can see that I have 9x plus 7, 9x minus 7 in pinkish color, 6 times the quantity 3x plus 1 in light blue. And then in turquoise we have, or seafoam green, whatever, 3x plus 1 times x plus 5 to give us that 3x squared plus 16x plus 5. So now again, you can see that we're dealing with a lot of that unit 1 kind of polynomial factoring stuff that come into play here. So what we're going to do is cancel, and you can see that we've got a 3x plus 1 here and here. They cancel here and here. And then one of the 9x minus 7 up here is, I'm going to make that a negative 1 because we have a 7 minus 9x. Remember that opposite. And so in the top, what we have left is 6. We have that factor 6 left. And we've got this 9x plus 7. And in the bottom, all we have left is the x plus 5 times 1. So now there's our answer in factored form. So the answer here, f over g, I'll write it like this, is then equal to 54, sorry. 54x plus 6 times 7 is 42. And then that's over x plus 5. Let me double check that. 54x, right, 6 times 9x plus 7. And then it would be over x plus 5. So there's our answer for the first part, f over g of x. And then for the second part, we want to just plug in 3. So we have f over g of 3. And that's in 54 times 3 plus 42 over 3 plus 5. So now I'm going through this pretty quickly because I want to make sure that you have this assignment. I'm going to let you finish that with a calculator. But if you find any mistakes, please let me know as soon as possible, and I'll fix them ASAP. All right, have a good day, and I will see you when I see you. And this is Unit 3 now on rational functions, and we just finished multiplying and dividing, where we did simplifying in 3.1, and then in 3.2, and there's my timer, 3.2, multiplying and dividing rational expressions.